Hi, this is Gordon with Maximum PC Magazine. I'm here to tell you about Intel's brand new Z68 chipset. It's the chipset that it hopes will replace the P67 chipset for Sandy Bridge on the high end. It's got a lot of really cool features, but I will tell you, it does mess with your mind. When I got this board, I wasn't sure how to set it up. The two new key features, the first one is the ability to use the onboard graphics chip. The Sandy Bridge, as everyone knows, has a really very nice graphics chip embedded inside the CPU on the die. But if you have a P67, you can't use it because there's simply no way to use that graphics chip. With Z68, you'll be able to use the onboard graphics chip and a discrete card. Of course, you're probably wondering why the hell you would ever want to do it. Well, I'm going to give you a couple demos of where the technology is cool. I'm not really sure it's going to work for all enthusiasts, but I will tell you it does have some promise, especially if they can really save some of the power savings they can get out of it. The board I'm going to be demoing this with is Asus's brand new P8 Z68V Pro board. It's a really nice board, probably going to cost maybe $200. I don't have the final prices yet, but Asus has decided with this board to give you the ability to use, again, the onboard graphics in the CPU as well as your discrete card. There's two modes. There's D mode and I mode. Right now we're running in D mode where we're plugged into your graphics card for discrete. This lets you run in SLI as well as using, and this lets you run in SLI and use the onboard graphics. But I'm going to show you one of the cool features that people probably don't really know about, and that is I'm going to use CyberLink's Espresso. We're using a demo version. It's version 6.5. I'm just going to take a VOB file and I'm going to convert it. Right now, we're going to be using the GTX 580 card in here. Let's select the file. I'm going to say select it for an HTC phone, just a generic profile. We're converting it to WMV. And right now, as you can see, it shows you the CUDA logo because we are running on this GeForce GTX 580 card. This, of course, is the fastest single GPU board out there. And you would expect that this GeForce GTX 580 will kick the crap out of the onboard graphics in Sandy. Okay, so now we're back in Munich Espresso. I'm going to take that same VOB file, drag it over, select my profile, same profile as before, click Go. And you'll notice the logo for the GeForce card is gone. It's now replaced with the Intel logo. So right now we're encoding this on the quick sync feature of the Sandy Bridge processor. So that's running in D mode where we're using the GPU. One issue with that, although you will get better performance in most games, is that this video card is going to be cranked up a little more. You're going to use a little more power. The Z68 with the Virtu Lucid Logic stuff also supports another mode called I mode, which we're going to switch to. It requires that you plug into the integrated graphics port. I'm going to actually restart because you just don't unplug it and plug it back in. You have to go into the BIOS there, or the UEFI on this case, and switch what it's going to boot from. So you're going to watch me do this. We're rebooting the system. So we're in the BIOS. I still call it a BIOS. Well, I guess it sort of is. The UEFI in this Asus board. I'm going to go to advanced mode. I'm going to go to advanced. We're going to go to system engine configuration. Right now, it's set to boot from the PCI Express card, a slot. I set this to iGPU, which means the integrated graphics. I'm going to save changes and reset. And I'm going to go to the board. And again, I'm going to unplug DVI from the graphics card. You can see I'm going to plug it into the DVI port on the motherboard. Come on. And hopefully this works. And what Virtu does is it takes the other graphics part and it virtualizes it. So earlier when we were using the QuickSync feature of Sandy Bridge, it was virtualizing the GPU that's in the CPU. So now we're going to reverse that. We're going to use the integrated graphics port. And when we have to do heavy lifting in a game, we're actually going to virtualize from the graphics card. Okay, so now we're running in I mode, which is running off the integrated graphics part. The whole idea of running off the integrated part is you're going to be using the integrated part for a lot of lower end 3D stuff. You're not going to be spooling up the discrete card as much. You're going to save a little bit of power. It's not quite as good as what we're seeing in laptops where they can totally switch off the discrete graphics part. That actually may change because NVIDIA actually has its own version of Virtu coming out for Z68. I believe it's called Synergy. And what I'm hoping when that comes out is that we'll be able to actually see the GPU get completely switched off, or at least turn off a lot more to save more power. But in iMode, let me show you the cool thing is, so now we're running off the integrated graphics part. We want to go ahead and play a game. We know the integrated graphics part is really not up to snuff to run a game, so I'm just going to fire up 3D Mark Vantage. And this should be running off of the discrete card. It virtualizes, again, the discrete card, displays it on the screen. It is, of course, running in virtualized mode because you're seeing the Virtu icon up on the upper left-hand side. And the idea then, of course, you will be using your integrated part. For most of the time when you're not playing games, you're going to save some power because this GPU is not going to be cranking up as much. But only when you play a game will it turn on. So again, right now, it's turning on. You'll be using more power. One issue with this configuration versus D mode is that Lucid Logic actually has to add profiles for new games before it really works. So will you really want to wait a couple weeks or a month for them to add a profile for a new game to enable it? I'm not so sure, but this very much is a cool feature. It feels a little early, beta-ish, and I think it's going to get a lot better. So here we are in the RSC control panel. We're going to use the Smart Response technology, which lets you take a cheap 20 gig SSD and cache the OS and often used files on your hard drive. On the other side, I have a 1 terabyte Western Digital black drive. So if I need to launch something, instead of it pulling it off of this very slow hard drive compared to the SSD, it comes off of the SSD. It's a little bit of a mind bender when you have to set this up because I wasn't sure, did I have to install the OS onto the SSD? Well, how do I set this up? It's pretty simple. You hook both drives up, you go into the BIOS, you set it to RAID, of course using the Intel Southbridge, not the Marvell or any other third-party parts. Once you do that, you load your OS to the hard drive, install the drivers, install your RST, go into a Smart Response Technology panel, click Enable Acceleration. You get this really spiffy control panel. If you, of course, you're wondering, what if I have a 200 gig SSD? What you can do is you can actually select how much of that SSD you want to use. So here it's only a 20 gig SSD, so you would use all of it. There's actually two modes to pick from, Enhanced mode and Maximize mode. Enhanced mode basically means if the SSD gets connected, you're not going to lose a lot of information because it's sort of like a cache, so you're not going to lose it. It's, it's going to be written to the hard drive, basically, at the hard drive speed, which means it's going to write pretty slowly. If you set it to Maximize mode, which I think most people will want to do, you basically get almost performance of the SSD in this setup. Intel says it's SSD-like performance. I think they're claiming about 4x performance over a hard drive. I've actually seen sort of similar technology from other companies. It's actually not bad. And let's see, I'm going to click OK. And there we go. It's set up. We're good to go. And of course, it's going to be a little tough to measure how much of an impact this is going to have on benchmarks. But I think it's kind of a cool feature. Again, it's going to be something that's going to be maturing as Z68 on Z68 over the next. So there you've seen Intel's new Z68. It's got some pretty cool features. This is Asus's board. The interesting thing is not everybody's taking this same tack. This board, of course, has the integrated graphics, output. It has the RST. It'll let you run SLI or Crossfire, but not everybody's doing this, which actually kind of surprised me. This is Gigabyte's brand new GA Z68X UD7B3 board. This is a Z68 board. It has, the big difference are, Enforce 200 chip, and very interestingly, Gigabyte said, well, we really don't think people are going to be using this kind of little wonky, integrated, discrete kind of, feature that you sort of have to bend over backwards to find a good use for. We're not going to have that at all. So basically, there is no access to the Sandy Bridge encoder, which will be interesting to see. But of course, the Enforce 200 means you'll be able to run, 3 NVIDIA cards in Tri-SLI. So I can certainly see where they're going with that, because if you're running Tri-SLI, I don't think you're really concerned about power savings at all anyway. And this is probably a better option for somebody who's really looking for, all-out, ultra high-end gaming. This may be a better option for people looking to sort of experiment with the integrated and discrete part. You will be able to save some power. When NVIDIA releases its Synergy support, we actually may see more significant power savings, so this may be a better option for that. We'll see as more Z68 boards come out and as the drivers and applications mature for them. That's all there is for now. This is Gordon Dunn with Maximum PC Magazine. Check out MaximumPC.com for more videos and information.